All right, let's go. Hello, people. Hey, if you haven't subscribed, please do so. There's a free PDF in English y Espanol in the description below, so feel free to print that out, do a little math, come on back, and then go over it with me. See how you done. Here's some linear functions word problems. A little bit more practice, all right? A little bit more practice. On Ray's farm, there's a water storage tank. The tank holds 5,400 gallons of water. Okay, so that's important information. That's an initial value, right? So I'm going to highlight that. Ray's on vacation, and the tank's spraying a leak. Uh-oh. The tank leaks water at an average rate, so there's that rate of 9 gallons per minute. Create a function, g of m, where m is the input value. All right, so m is the input, and g of m is the output. All right, let's do it. Highlight the initial amount and the rate of change in the word problem. Hey, I already did that. What is the initial amount? Okay, the initial amount is 5,400 gallons of water. What is the initial, identify the rate of change. The rate of change is 9 gallons per minute. All right. This is not bad. Create a function g of m. Okay. Here it is. Here's my g of m equals, with the information above that models the amount of water in the storage tank. Okay. Notice the amount of water in the storage tank is decreasing, right? Because it's decreasing, that means my rate of change is negative. So it's negative 9 gallons every minute, right? So that's how we change, negative 9 gallons every minute, and we start with 5,400 gallons. All right, so that's our equation. Okay, let's do it. We got to find some important things. So important thing number 1 is the number of gallons at 0 minutes. Well, that's easy. The tank hasn't leaked. There's 5,400 gallons in it. This is the tougher part, and that is how much time did it take for there to be 0 gallons, right? That's important because that's when we know it's done. Because if there's no more water left in the tank, it can't leak no more. So how I'm going to do it is I'm going to take my total amount of gallons in the tank and divide it by the rate at which it flows out. And if I do that, it's going to tell me how many minutes it took for the tank to empty. So 5,400 divided by 9. That means 600 minutes. Okay, so now it also tells me, hey, we want you to make a table with 5 inputs and 5 outputs. Okay, so let's do it. I'm going to pick 3 more values, and I'm just going to pick them just as long as they're between 0 and 600. And I'm going to pick them so they span nicely, okay? I want to pick ordered pairs that span nicely. So I'm going to pick 200, 300, and 400. You could have picked 100, 250, 500. You could have picked different numbers. Those are the ones I picked. Now I'm just going to input those into my function one at a time. So I'm going to put those in for minutes, right? M is minutes. And then when I'm done calculating that, that'll give me the amount of gallons left. So I'm going to do negative 9 times 200 plus 5,400. I would have 3,600 gallons left. All right, let's do it again. But this time I want to know how many gallons are left after 300 minutes. That would be 2,700 gallons. And then the last one I'm going to do is negative 9 times 400 gallons. 400 minutes, sorry. And that will tell me the number of gallons left, 1,800. Notice it's decreasing, right? So as the time is increasing, the water's decreasing, which should be happening. All right, is this continuous or non-continuous? Well, this function is continuous, and it's continuous because fractional answers or minimum amount of water can leak out, right? And time is usually always continuous. So the water is continuously leaking out. It's not coming out in a bucket full, right? So it's continuously leaking out until empty. Ooh, that was pretty good. That was pretty good. There's a lot of ways to say something like that. Okay, we're going to graph it. All right, so when we graph this, we're going to go ahead and use minutes as our independent variable, our input. So these are my minutes, and these are the gallons left. I got to go to 600 minutes. So I'm going to do increments of 50. I have 20 to work with, so I want to use at least 10, if not more. That would give me 12 units, all right? So 0, 50, 1, 152, 253, 354, 455, 556. All right, so that's for minutes. Now we have on the dependent axis, the y-axis, we have gallons. I got to go up to 5,400. So I'm going to do increments of, I'm going to do 500. I like to pick nice increments like 50, 500, 10, 20, 1,000, things like that. But I also want to make sure I span at least half of my coordinate plane. So 0, 500, 1, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, 5,000, 5,000, 5,100, 6,000. All right, now we're going to graph it. To graph this, I'm going to plot 2 points. The points I'm going to plot are my minimum time and my maximum time values. So minimum time is 0, 5,400, and that's about there, a little under 550. The maximum time when the tank reaches 0 is 0, 600. Now we know this is continuous. So this graph is going to be continuously leaking water, not just in bucketfuls, but it's going to have a continuous leak. And so every time increment is valid. So I'm going to make that a continuous graph. Notice I do not go past my minimum and maximum values because it wouldn't make sense. To go down here wouldn't make sense. There's no water left in the tank. So why would I go here? And you can't have negative amount of water in the tank. And that's what happened below the y-axis. Over here, that would be negative minutes. And negative minutes doesn't make sense in the context of this problem either. So the only valid inputs and outputs are from this end point and this end point. All right, let's keep going. Identify the minimum and maximum output values. Hey, output is gallons. So the minimum is when there is 0 gallons. Minimum is the smallest amount. And the maximum is when there is 5,400 gallons. That's not bad. Okay, how much water was left in the tank after 3 hours? Hey, wait a minute now. We need to convert that to minutes. So I'm going to do 3 times 60. That's 180. So 3 hours is equivalent to 180 minutes. I'm going to substitute that into my minutes. So I'm going to go -9 times 180 minus 5,400. And we will have, that didn't go well. I think what I should have done is I should have made that a plus instead. 3,780 gallons. That's how many gallons would be left after 3 hours. And that's equivalent to 180 minutes. Notice how on these problems I'm using units of measurement. You should too for full credit. All right, this question, how many minutes? So now you're looking for the M value. How many minutes did it take for the tank to have a total of 3,717 gallons left in it? So this represents my output value. That's my output value. Okay, so I'm going to go to my model, and where I see a G of M, so I'm going to go ahead and write that here so you can see it. This represents my output. So that becomes 3,717. I'm going to solve this for M. So I'm going to subtract 5,400 from both sides because I got to solve the equation for m. So inverse operations. I'm going to go to my calculator and I'm going to do 3717 minus 5400. I get 1683. So that means 1683 negative 1683, equals negative 9m. Now I'm going to divide both sides by negative 9. So negative 1683 divided by negative 9 is 187 minutes. Let's go. So 187. Again, use your units of measurements, please. All right, that's not bad. That's not bad. Hope Ray got home in time to fix that and they didn't lose any crops. Okay, here we go. A student at Churchill High School wants to earn a total of $480. Okay, that's a total. That's important. To donate to the local animal shelter. Nice job. I like this person. All the supplies were donated. Awesome. Great community. They went to sell homemade wood boxes. Okay, so they're going to sell wood boxes and mirror shelves. Okay. The student will charge $10 per box. Okay, that's important. That's a rate. And $6 per shelf. That's also a rate. So I know if I'm dealing with two rates in a total, this is standard form. Standard form is A times the input variable X plus B times the input variable Y is equal to C. This is a rate. This is a rate. And this is a total. Okay. Assign variables. Okay, well I'm going to let B equal box. And really it's boxes sold, right? And I'm going to let S equal shelves sold. There it is. That's not bad. The first rate is the rate for boxes. It's $10 per box. Per is the word that tells me it's a rate. And the shelves are $6 per shelf. And then I have a total that I'm going to earn is $480. Okay, that's not bad. That's not bad. We're going to write a two-variable equation. So I'm going to use the rate times the number of boxes that I sell plus the rate times the number of shelves that I sell. And that's going to equal a total of $480. So far, so good. All right. Let's make a table of values. All right. So what if I sold 0 boxes? Well, if I sold 0 boxes, that means I sold 480 divided by 6 shelves. So 480 divided by 6. That would be 80 shelves. Now, if I sold 0 shelves, boom, that would be 480 divided by 10. And that would tell me the number of boxes because it's $10 per box. So the total divided by the amount per box will give me the total box sold. That's 48. Okay, now, this is the tricky part. I got to pick 5 inputs and outputs. Pardon me. Right there, 5 inputs and outputs. When I pick inputs from my boxes, I want to make sure that they're going to be increments or multiples of 6. So for example, I'm going to pick a number like 12. And then I'm going to pick 24. And then I'm going to pick 36. Notice that 12 goes into all of those. All right, now what I'm going to do is I'm going to input those in for the boxes. So I'm going to go to my function or my equation, and I'm going to go 10. Where I see a B, I'm now going to replace it with the value, the number of boxes that I want to put in. So let's say I sold 12 boxes. Well, that's $120. Subtract 120 from 480, and you get 360. Divide 360 by 6, and you get 60. So that means if I sold 12 boxes, to make $480, I have to sell 60 shelves. Now I'm going to do the same thing, but now I'm going to let B be 24. Notice how picking multiples of 6 to input for the boxes was very helpful. It means all of my answers are going to be non-decimals. So now I'm going to put a 24 there. That gives me 240. Subtract 240 from both sides, because remember we're solving this equation. And that gives me 240. Divide both sides by 6, and that gives me 40. I see a pattern. As I increase this by 12, this decreases by 20. So increase by 12, decrease by 20. Okay, there's my 5 inputs and outputs. This is non-continuous because I'm not going to sell half of a shelf or half of a box. So only whole number answers work. Okay, let's graph it. Now to graph this, I have boxes over here. All right, and I have shelves here. I like to look at my table. Whatever my first column is, that's going to be my horizontal axis. Whatever my second column is, that's going to be my vertical axis. So shelves is going to be Y, boxes is going to be X. With boxes, I got to go from 0 to 48. So I'm going to do increments of 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. With shelves, I got to go to 80. I'm going to do increments of 5 there as well. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay, now let's plot our two maximum and minimum points. So minimum boxes, maximum shelves, maximum boxes, minimum shelves. So 0, 80. Hey, that's kind of easy. Right there. All right, and then we have 48, 0. So 45, 48 is about there. Now when I graph this, I'm going to make sure and make it look non-continuous. So I'm going to make my line dashed. Look at that. That's pretty. That is pretty. Let's answer some questions. Okay, question number 1. How many shelves were sold if there was a total of 24 boxes sold? Hey, I already know that answer. That's in my table. Right there, 24 boxes, 40 shelves. I got lucky. $40 shelves. Okay. How many boxes were sold if there's a total of 35 shelves? That one did not land on my table. So, I'm going to go to my function, and I'm going to put in 35 for shelves. Okay, that gives me 10b plus, that's 210. Subtract 210 from both sides, and I get 10b is equal to 270. Divide by 10, and I get 27. So 27 boxes. All right, here we go. Last question. Is it possible to reach a target of exactly 480 if 28 shelves were sold? Well, let's check. 10b plus 6 times, where I see an S, I'm going to replace it with that value. Right there. 10b plus, that's 120 and 48, that's 168. Subtract 168 from both sides because we're solving this equation for b. This is why we taught you how to solve equations. You need that skill throughout your mathematics. That gives me 312. Divide both sides by 10, and you get b equals 31.2. Is it possible to sell 0.2 of a box? No. cannot sell 0.2 of a box. Okay, that's it, people. Good job, good job. I like the way you handle your business today. Not having distractions in front of you. That's good work. Enjoy it. See you soon. Bye.